Hello, welcome to Two's classes once again. Today I am going to discuss a very important topic in 12th class cbse physics, and that topic is the application of superposition principle, yani how we can use the superposition principle to solve some numerical problem. One problem I am going to discuss with you, that is the force on a charge at centroid of a triangle. Okay, we are going to discuss it. I have considered what I have considered. We have a equilateral triangle. We have an equilateral triangle ABC of each side small a. I have considered that the each side of this equilateral triangle is small a, and we know that in equilateral triangle are those triangles in which all sides are equal. Okay, and what I have to do, I have to calculate the electric force at a point charge, which is a small point charge plus q, which has been placed at its centroid. Let us see how we can calculate. I have considered an equilateral triangle ABC of each side a. Suppose charge plus q is placed on its each vertices. Okay, what I have considered, a charge plus q has been placed on each of its vertices, and centroid. Let's see how we can calculate the centroid. We draw the normal from point B on the side AC. Similarly, I draw one normal from point A on side BC. In the same manner, I have drawn one normal from point C on side AB. Where they intersect each other, that is known as centroid. Suppose this centroid is O. I consider a very small point charge, small plus q is placed here. I have to calculate the net force which is acting on this small point charge plus q due to the other large charges. Okay, let us see this normal is AD. Okay, this is normal AD. We know that in equilateral triangle each angle is of 60 degrees, so therefore this angle will be of 30 degree. Any confusion? Equilateral triangle, on each of its vertices plus q plus q plus q charge is placed. O is the centroid. At centroid a small charge plus q is placed. I have to calculate net amount of electric force acting on charge plus q. We have to apply here superposition principle. Let us see how we can do that. So before that I have to calculate the taking triangle. I take triangle ABD. Let us see, in triangle ABD I can write down AD upon AB, that is equal to cos 30 degree, and you know that cos 30 degree is equal to under root 3 by 2. It implies that AD is equal to AB under root 3 by 2, or you can write AD is equal to, as AB is the side, A under root 3 by 2. So what I get, this length AD, that is equal to A under root 3 by 2. From geometry I know that, but I have to write down the distance AO. This distance AO, that should be equal to 2 by 3 AD, that is from geometry. In mathematics, you have studied the properties of the equilateral triangle, that's one of them, and you can write AO is equal to 2 by 3 AD. Okay, now I have to write down, therefore AO, that comes out to be 2 by 3 into A under root 3 by 2. 2 get cancelled, and as a result I get A under root 3. So AO is equal to AO comes out to be that distance AO is equal to A under 3. But once again from geometry, AO that is equal to BO that is equal to CO. It means this side, this side, this side, they should be equal to each other. That's the important property of an equilateral triangle. Okay. So I get AO is equal to BO is equal to CO. Now force, I have to write down force exerted by charge plus Q at A, at point A, on small point charge small plus Q at, which is at point O. Suppose this is equal to F1, then I can write F1 is equal to 1 upon 4 pi epsilon naught upon AO whole square, like this one. As these two charges are positively charged, definitely the direction of F1 will be this one. This is the direction of F1. Okay. Now, or you can write down when you place the value of AO 1 upon 4 pi epsilon naught QQ AO is equal to A under root 3 square. It comes out to be 1 upon 4 pi epsilon naught 3 QQ upon A square. And this is along, what is the direction? This is along AO. So I have write down here what is the force which is exerted by charge plus Q, with charge plus Q at small charge plus Q, which is placed at centroid of an equilateral triangle. Okay. Similarly, I can write down F2. What I have considered F2, that is force exerted by charge which is at point B on charge plus Q which is at point O. Similarly, I can write down the FO. That should be equal to 1 upon 4 pi epsilon naught 3QQ upon A square, but direction will be different. Magnitude is same. The direction is along B. Similarly, F3 is the charge. F3 is the force exerted by charge at point C on charge plus Q at point O. That is F3. This is F3. So like this one, this is the directions of the forces. I am going to write down the value of F3 here. You can write 1 upon 4 pi epsilon naught 3QQ upon A square, and its direction is along, you can see the direction is along CO. Okay. I have to calculate the net force, so I have to apply the principle of superposition principle here. So net, therefore the resultant force from principle of superposition, resultant force acting on plus Q at point O, that should be equal to, principle of superposition states that is equal to the vector sum of the forces which has been applied by each charge on this test charge or the small positive charge. That comes out to be F1 plus F2 plus F3. Now I have to calculate this F1 plus F2 plus F3. You see here, this is the direction of F1, this is F2 and F3. So I have to apply the parallelogram law of vector addition here, and the parallelogram law of vector addition I have to apply. So you can write down now resultant of F2 and F3. Okay. So I have to write down the magnitude of this one, resultant magnitude resultant magnitude of these two forces, you have to apply the principle R is equal to, you have studied, suppose that is R, that should be equal to F2 square plus F3 square plus 2F2 F3 cos theta. Okay, so you have studied R is equal to 1 to P square plus Q square plus 2PQ cos theta. So here I have write down the resultant magnitude of the forces F2 and F3 given by this expression. Here this angle should be 120. With the help of geometry you can calculate. Okay, that will be 120. So when I apply the value, let's see what result I am going to get. The resultant comes out to be, actually F2 and F3 they are same in magnitude, so I can replace F2 by F3, or I can write F2 square plus F2 square plus 2F2 F2, and that is cos 120. Why I have do so? Because the magnitude of F2 is equal to magnitude of F3. So I have replaced F3 by F2 because they are equal in magnitude. When I solve them, you see what I am going to get. 2F2 square plus 2F2 square and value of cos 120 minus 1 upon 2. So as a result you get 2F2 square minus F2 square, you get F2 square, that is equal to F2. So what I have get now, the resultant of these two forces is equal to F2. Actually from these three, F1, F2, F3, you come to know magnitude of each force is equal, but resultant, how you can calculate the resultant? You have to complete this parallelogram like this one. This is the parallelogram, and this diagonal that will represent the R. So what we have observed, R is equal and opposite to F1. R is equal to R is in magnitude equal to F1, but it is opposite. So therefore we can write net force F acting on this charge will be equal to 0. I hope that you understand it well. If you have any problem, then kindly send your comment in comment box. Thank you very much.